So now we get into carbonyl chemistry, and carbonyl chemistry actually makes up about half of this course. And so in this first section on carbonyl chemistry, we're going to be looking at aldehydes and ketones. And we group these two functional groups together because they're both very similar structurally. Both of them are carbonyl with an R group on one side. And of course, the difference is that the aldehyde has a hydrogen on one side and the ketone has another carbon group. But realistically, and in terms of the way they react, the two functional groups are very, very similar. All right, but before we get into any of those properties or their reactivity, we're going to start by talking about some nomenclature. So aldehydes are definitely one of the easier groups in terms of nomenclature, and we'll see why in a moment. And ketones are, there's a lot of similarity to the nomenclature of alcohols that we have with ketones. So let's start by looking at ketones and seeing what we mean. So if you recall with alcohols, we numbered our parent chain so that the carbon with the alcohol got the lowest possible number. And then something like this we would have called 2-pentanol. Well, ketones behave in exactly the same way. We number the chain so that the carbon with the ketone gets the lowest possible number. The only thing that's different here is the ending. And the ending that we use for ketones comes right out of the name, ONE. So this 5-carbon molecule with a ketone on the second carbon instead of 2-pentanol is 2-pentanone. Just like we saw with alcohols, sometimes we need to put that number in the middle of the name. Same thing can be the case for ketones. If we need to do that, it becomes pentane 2-one. But otherwise, the nomenclature of ketones, there's really nothing new about it. It's just exactly the same as what we've seen with other functional groups, but a different ending for the carbonyl group. Now, what about aldehydes? Well, aldehydes are actually a little bit easier. And the reason that aldehydes are a little bit easier is because an aldehyde is always the end of the chain. Because it's a carbonyl bonded to a hydrogen, the chain always terminates where there's an aldehyde. And so because of that, the aldehyde carbon, the carbonyl of the aldehyde, is always carbon number 1. And so that makes our nomenclature quite a bit easier because we know from the past that often one of the more annoying pieces in nomenclature was trying to determine which direction to number the chain in. With aldehydes, we don't have to worry about that because we always define the carbonyl carbon as carbon 1. The only other thing we need is what is the ending that we use for aldehydes. And again, it comes right from the name of the functional group, Al. So this molecule here is 6 carbons, and therefore is known as hexanal. Notice also, and this is important, there's no number here. And again, that's because the aldehyde carbon is always carbon number 1. And so because it's always carbon number 1, we don't have to worry about giving it a number. In fact, if you did give it a number, and say you had decided to name this as, 1-hexanal, technically that is not correct because there's no number used for the aldehyde. Other than that, though, the nomenclature of aldehydes and ketones is identical to everything else we've learned about every other functional group, including things like making sure you have your substituents in the correct order, as well as things like R and S and E and Z. The only other situation that can be a little bit more complicated is what if we have both? So what if we have both a ketone and an aldehyde? If we have both, the aldehyde gets priority. And so we would number this based on carbon 1 for the aldehyde. And so you can see we have 5-methyl hexanal. But what do we do with the ketone? Well, if we have a group that's higher priority than the ketone, the aldehyde here is an example. In the next section, we'll cover carboxylic acids, and that's another group that gets priority over the ketone. Then we have to name the ketone as a substituent. What do we call the ketone as a substituent? It's referred to as oxo. So since we have a ketone on carbon 4, this becomes 5-methyl 4-oxohexanal. So at this point, you'll want to take a look at in-class exercise number 7, which will give you some practice dealing with nomenclature of aldehydes and ketones.